Welcome everybody to Restoration Projects Monitoring Lecture 2. This will be our final lecture for the class. So yeah, it's been a heck of a semester. I've really enjoyed working with y'all. And if you have any questions, comments, or thoughts, let me know. I'm gonna try to hold our regular Google Hangouts this next week. But drop me a line or an email if you want to get together and discuss anything at all. Hope you've enjoyed the class. It's been an experience, but I've enjoyed working with y'all. So last time we talked about ways to monitor restoration, and one approach is just to collect data over time on a site and hope that the effect is strong enough and obvious enough that you won't need to run statistics and data like that. But there are problems with that. First being that it has to have a very large effect. The second being that it can be complicated by trends of change over time. So the next two approaches find a way around this. So the before-after control impact, or BACI designs. So the BACI design goes kind of like this. First, you have to determine an impacted site, a site that is going to experience some sort of change, and then a control site, one that will not experience that. So then the idea is that you collect data beginning before the disturbance and proceeding to after the disturbance, and then you examine the extent of change over time at both sites. And what I suppose you're sort of hoping is that there will be a greater change after the disturbance at the impacted site than there would be at the control site. But by doing this, you can see what's happening, right? You're controlling for change over time by collecting data at a site that is not experiencing whatever impact you're going to be subjecting it to. So in the last lecture, we talked about the idea of a positive control being a site that represents the condition that you would hope your restored site will achieve, whereas a negative control represents the degraded state that you're hoping your restored site will rebound from. So a question for you, if in a BACI design like this, if we're looking at restoration as being the impact that a site will experience, the question is this an example of a positive or a negative control? And so in the case of a restoration impact, this would be a negative control, because what you're hoping is that the control site is in about the same condition as your impacted site to begin with, but that over time your impacted site will get better than that control site, and that control site, all other things equal, you'd expect would kind of stay the same. So this is employment of a negative control and issue. Sorry, got cut off on the slide before. So BACI actually uses a negative control, which there are some issues with, but it will in the absence of a pristine site to compare to it might be useful. So as I mentioned, the whole idea is that we collect a sample at the unimpacted site and one at the impacted site before and after the disturbance. So I'm going to share an example that we did using fish density. So before I'm just making up a hypothetical case here. So let's say before the disturbance, there were more fish at the control site than the disturbed site. After the disturbed site number came even lower, where the control site increased slightly. So if one site changes over time and the other doesn't, then we conclude that that event had an effect. So it looks something like this, right? We're essentially testing the difference between our control and our disturbed site before the disturbance and then after. And in this case, you can see that value increased. Any issues that come to mind with that idea? So once again, we have the problem that there could have been a bunch of things that happened between those two sampling points in addition to the restoration, right? So you're still dealing with this confounding effect. All right, so the Bakke design was extended to include multiple before and after samples at each site. And the reason for this is because the more samples you have, the less likely you are to be affected by specific events that occurred at a time and affected one sample or another. The more samples you take, and you take the averages of them, you start to sort of smooth out all that variation. So the idea now is that you can compare means of the difference between the control and impacted site before the disturbance to means of the difference after the disturbance. So just to share an example of a project that I was involved with, working on the Narayani River in southern Nepal. I came onto this in the data analysis portion. Data were collected in the 80s and 90s, and I helped with the analysis during my master's at Emporia State out in Kansas. And this was looking at the effects of a paper mill on fishes and macroinvertebrates in the Narayani River in Nepal. So here's a picture of the river. It's we were down in the lower section, so it was a fairly broad, deep river. So there's this paper mill that began operation in December '86. It was one of Nepal's largest paper producers for decades, and it's currently closed. But my collaborator, Dr. David Eds, had the vision to start taking samples before the paper mill began operation to see what kind of impacts it was having on the river. This is a picture of the site from our visit there in 2015. You're looking downstream, and not far downstream from here, the river enters a national park, and it's a pretty neat place. It's got tigers and rhinos and wild elephants, among other things. This is a picture of the paper mill. It's not in operation now. We couldn't get up and get a really close picture, but you just see the smokestacks there. And this is the little channel that the effluent would move out through, and so it would come out through there into the river itself. And this is right near where the effluent used to come in, and so we were in there sampling the fishes. This is, again, a picture from 2015 after the study was done, but we wanted to follow up and see how things have been looking since then. All right, so if we think of that paper mill opening as the impact, right? So it happened right where that red line is in the cold and dry season of '86. So just to orient you, we've got our data going from 1984 up through '86, and then again in '87, and then in '96 as well. And so the site that's downstream has the dashed lines. It was the one downstream that was affected by the paper mill, and upstream is a solid line. That was our control site. So if you just look at the data there, looking at the number of fish per seine haul, and then the number of species per seine haul, or per site, actually, excuse me. It turned out that the difference between those sites was not significant for the number of fish, but it was for the number of species. And so the way that the analysis works is that you take the average of upstream and downstream, and then take the difference before and then the difference after. And so you can see that before the mill opened, the downstream site averaged about 9 species. The upstream site averaged about 8.5. But then after, the upstream site increased to averaging about 10.5 species per site. The downstream site dropped to about 6. And so when you take the average for each of those sampling periods and compare them, it's in fact significant. You can tell, especially in the 1990s, there's a big difference there, right, between the downstream and upstream sites, the control and reference sites. Benthic macroinvertebrates, on the other hand, looking at the data there, any thoughts? A lot of fluctuation, right? See how little was collected during the monsoon. Really interesting. These rivers are incredible ecosystems. You get so much water moving through there in the monsoon, it just resets everything. There's not many invertebrates able to live there in the monsoon, so they have to adapt their life cycles, right? So what it turned out, again, particularly in the 90s, but then in the cold, dry season of 87 as well, is that there were a lot more macroinvertebrates at the upstream site than in the downstream site. Whereas below, with a number of taxa, they pretty much followed on top of each other, the downstream and upstream. But the average, looking up above, the average number of invertebrates at the downstream site was about 35, and upstream was 134. So pretty dramatic difference. Okay, well, are there still any issues with this Bakke design? Well, looking at this result here, something might come to mind. One of the issues is that a change in either site can lead to detection of a disturbance effect. So if you look for the data on number of species after the mill was constructed, really what caused the difference between the upstream and downstream sites to become great was not a massive decline in the number of species downstream, right? It declined a bit, went from 9 to about 6. But on top of that, it was a pretty strong increase in the number of species in these upstream sites, from about 8.5 to 10.5. So what that's telling us is that at our control, there was an increase in the number of fish species, and that contrasted a moderate decrease in the number of fish species at the downstream site. So the Bakke design, because it's based on that difference, you know, a significant effect can be driven by changes to either site. Some other considerations with Bakke. Again, so this is kind of what we said, right? Change in either site can lead to detection of a disturbance effect. Change in the control site can mask a disturbance effect, right? So if there's a decrease in fish species at our disturbance site, but then there's a similar change in our control site, it can mask that. The whole issue that we've talked about of establishing reasonable control sites is a problem here, right? So you know, you don't necessarily know beforehand if that site is going to be affected at all. This part as well, sometimes you can't sample the control and impact sites simultaneously. So if you sample the control and impact sites at different times, then we'd expect them to be different anyway. And interestingly, you often don't know the scale over which the environmental effect is going to operate before it happens, right? So with our example with this paper mill on this river in Nepal, we can be pretty confident that it was not going to be affecting this other site a couple kilometers upstream. But who knew how far downstream that impact was going to be felt? You know, it's really hard to say. Really hard to say. So that can affect your controls, right? You don't want to pick a control that's within the scale of an effect, you know, because that's clearly gonna not be an effective control. All right, so another technique we can use is what's called the space for time substitution. And I'll show an example of how this works using grassland restoration in Europe. This is the Hordobaji National Park in Hungary. It's the largest contiguous natural grassland in Europe. And so these authors wanted to look at how restoring the grassland affected orthopteran assemblages. So this area that they were looking at restoring had previously been used for agriculture. It had alfalfa, sunflower, or cereal fields. And these fields were all prepared by one round of deep plowing, followed by 2 rounds of smoothing, right? So this is to kind of disrupt that agricultural residue. And then they were seeded with a seed mixture that only had a couple grass species. It was a mixture based on the soil type. So the idea was to seed it with these native grasses. And then they wanted to see what would happen to the orthopterans, right, the grasshoppers. Okay, so what do we mean when we say a space for time substitution? So these authors in their study had an area that was still cropland, an area that was natural grassland, and then they had sections that had been restored. And they had sections that had been restored 1, 2, 3, or 4 years previous. Then they had other sites that they tracked for 4 years post-restoration. So when the restoration occurred, they already had different sites that were in different stages of succession after restoration. But then for their study, they also tracked other sites for 4 years. So basically, a space for time substitution says, instead of having to track our site for 4 years, if we can find 4 different sites that were restored 4, 3, 2, and 1 year ago, then our snapshot of the condition of those sites now tells us about what happens at these sites over 4 years. So you're looking at different sites instead of following your same site over time. Okay, so first they looked at effects of restoration on abundance. How did the space for time approach compare with looking at change over time? So on the left is the change over time. And so these are the number of years since restoration happened. And you can see, particularly in years 3 and 4, there were definitely more orthopterans. Similarly, when you looked at restoration year, so if it had just been restored in 2008, or I'm sorry, in 2008, then it had had 1 year since restoration. 2007 it had 2 years. 2006 3 years. 2005 4 years. And similar conclusions, right? In the sense that 2005 had the highest abundance, although the pattern was not as consistent. So it looks like you could catch the same trend in abundance, whether you did sampling all 5 years or did a space for time substitution. So in this case, we had an example of an effect that was detected by both methods. All right, well, what about the numbers of species? Okay, so over on the left again, sampled all 5 years. So an initial decrease in the number of species in year 1 since restoration. But then from year 2 on, we see increases where we have actually more species than we had before. All right, but now with our space for time substitution, things are a little more murky. And in fact, that was not significantly different statistically, whereas the trend over all 5 years was. So in this case, the conclusions about the effects of monitoring differ depending on what techniques were used. So, in case you're curious, their conclusions on the restoration effects of grasslands on orthopterans was that overall increased abundance and species richness was observed. It didn't depend on restoration method. And they found that generalist species arrived first, right, as we might expect with succession, followed by specialists and or rare taxa. So then over this 4-year monitoring period, species composition became more similar to reference grasslands, but still differed. So at least over 4 years, that wasn't enough time for the grassland to completely for the restored grassland to completely resemble the natural one, but it was headed on the right trajectory. But they found that a space for time substitution was not effective at detecting differences in species diversity and composition. You really had to sample the same site year after year to be able to catch that. So some of these more subtle differences might not be apparent using space for time. In some cases, that repeated measures sampling might really be necessary. All right, so what are some of the advantages and disadvantages of a space for time substitution? Well, the advantages are that it's convenient and quick, right? So if you have a mosaic of restoration projects, some of which are in different stages of succession, then you could sample all of those sites and get a snapshot of what restoration looks like over multiple years, as opposed to having to sample the same site year after year. And it looks like some effects are detectable. But the downside is that it doesn't account for natural variation among sites. So, of course, if you sample the same site year after year, then you're not going to have to, you can essentially rule out that source of variation. But when you have, say, 5 sites sampled that were restored in different years, those sites might differ slightly with regard to abiotic or biotic factors. And so that kind of variation, you're hoping, just gets canceled out, but wouldn't necessarily be the case. So the question of how we restore these sites then is an important one, right? Because we really have to learn from experience and see what works with restoration and what doesn't, and build on what works. But as we've seen, it's problematic, right? These are unreplicated perturbations to systems which are not easy to study ecologically. So we have to take advantages of a couple approaches, including the Bach approach and the space for time substitution. All right, well that's it for this lecture. It was a lot of fun going through. I'll tell you, I get excited about this stuff. I've been learning a lot about restoration from collecting data around here in the mountains, and I hope to continue to do it for quite some time. Hope you found this class useful. And like I said, any questions about restoration, I'm always happy to answer them anytime at all. So take care of yourselves, and I'll talk to you soon.